So phase of vibrations. This refers to the angular displacement. The angular displacement of the vibrations along a wave. The angular displacement of the vibrations along a wave. It can also be described as phase angle. Phase angle. As phase angle. And it is measured in radians. So that is the unit for it. Radians. Radians. And you can put a circle down and identify the four main phase angles that you can have. You can have pi over 2 radians as one phase angle. You can have pi, another phase angle. You can have 2 pi, another phase angle. Then you can have 3 over 2 pi, all in radians. So these are the four main phase angle values that you can use to describe the phase of vibration of a wave. Hurry up, hurry up. Alright, now, whenever vibrations occur at the same phase angle, or whenever vibrations have the same phase angle, they are said to be in phase. Is it clear? You can add that. Vibrations with the same phase angle, vibrations with the same phase angle are said to be in phase. In phase. And then vibrations with different phase angles. Vibrations with different phase angles are said to be out of phase. Said to be out of phase. Out of phase. Now, if we have vibrations and then they are out of phase, it means there's a difference between their phase angles. That difference is called a phase difference. So the difference between two phase angles is called phase difference. The difference between two phase angles is called phase difference. Phase difference. and you can find the phase difference if you know the distance for them. So if you have 2 points along a wave, for example, if this is my wave, and I have 2 points, point A and then point B, and then they are separated by a distance x, then since they are not having the same phase angle, there is a phase difference between them, and I can find that phase difference by using the expression phase difference and the symbol phi, and that is given by phi is equal to 2 pi x over lambda. So for a distance x, phase difference is 2 pi x divided by lambda, where lambda is your wavelength. So you can easily find the phase difference between two vibrations, provided you know the distance between them. You can use the expression to find the phase difference. Alright, so these are the terms that you can use to describe any wave motion. So as we continue the lesson, whenever I talk about cycle, I expect you to understand what I mean. When I talk about phase angle, phase difference, amplitude, crest, trough, wavelength, I expect you to know what these things are. Is that clear then? Alright, any questions, at least with what we have discussed so far? Any questions that you want further clarification on? You can let it be known that we tackle it. Question on these particular things. Write this question down and then we'll look at it. A wave with frequency 3.0 Hertz. A wave with frequency 3.0 Hertz. A wave with frequency 3.0 Hertz. Takes 1.7 seconds. Takes 1.7 seconds to travel a length of 2.5 meters. To travel a length of 2.5 meters. To travel a length of 2.5 meters. Determine the wavelength of the wave. Determine the wavelength of the wave. I take the question again. A wave with frequency of 3.0 Hertz takes 1.7 seconds to travel a length of 2.5 meters. Determine the wavelength of the wave. Alright, so frequency is 3.0 Hertz. What else do we know from the question? Time. What sort of time is that? Read the question well and tell me the time that particular number is referring to.
A wave with frequency 3.0 Hertz takes 1.7 seconds to travel a length of 2.5 meters.
So that is not period. It is time for the wave to travel a particular length. In other words, time for a length of 2.5 meters. So we know time, generally time. So time is 1.7 seconds. What again do we know about the wave? It travels a length or a distance of what? So let's call that x, distance, x. 2.5 meters. And what are you supposed to find? Wavelength. So we are looking for wavelength, which is lambda, and that is what we don't know. So now we find it. Now we need an expression that can help us to find wavelength. What expression can we use to find wavelength? What expression can we use to find wavelength? Yes, Biker. V is equal to, alright, so from V is equal to F wavelength. Wavelength is equal to what? Speed or velocity over what? Frequency. We know frequency, right? Now we need velocity. We must find it. And how do we find the velocity? So we use distance or displacement over time to find the velocity. So V is going to be S over T. Our S is already in meters, so we don't need to do any conversion. T is already in seconds, we don't need to do any conversion. So it means that V is equal to S is 2.5 divided by 1.7. So what is going to be the velocity? 1.47 meters per second. So now that we know the velocity, we were given frequency, so we can find the wavelength. So this implies then that the wavelength is going to be 1.47 divided by what? 3.0. So 1.47 over 3.0. I will get what? 0.49. 0.49. What will be the unit in meters? So approximately 0.5 meters. So that will give you the wavelength of the wave in question. Is it clear there? Let me give you one for you to try, then we can end the lesson. So write this final question down. What is the wavelength of a wave which has a frequency? For this question, one of you will come to the board to do it. What is the wavelength of a wave which has a frequency of 5.45 times 10 to the power negative 7 hertz? 5.45 times 10 raised to the power negative 7 hertz. If it travels with a speed, if it travels at the speed of light in a vacuum, if it travels at the speed of light in a vacuum, if it travels at the speed of light in a vacuum. What is the speed of light in a vacuum? Alright, so 3.0 times 10 to the power 8 meters per second. Alright, so I'm giving you 2 minutes. Afterwards, I'll call one of you to come to the board to do it. I take the question again. What is the wavelength of a wave which has a frequency of 5.45 times 10 to the power negative 7 hertz if it travels at the speed of light in a vacuum? And the speed of light in the vacuum is 3.0 times 10 to the power 8 meters per second. Are you still in this class? Alright, so one of you should come to the board and then do it. Biker, come to the board and do it for us.
Okay, so we have our frequency to 5.45 times 10 to the power minus 7. And the question says that it's traveling with a speed of light in vacuum, and we know that to 3 times so there's the speed of light in vacuum, and that's our velocity. And we also know velocity to be wavelength times frequency. So if we make wavelength the subject, we'll get something like this. Are you there? Yes. So if we substitute our values in, we have the velocity to be 3.0 times 10 to the power 8 all over our frequency, which is 5.45 times 10 to the power minus 7. So if we punch this on our calculator, I'm going to get something like, so our wavelength is going to be equal to 5.50 times 10 to the power 14. Yeah.
All right, clap for him. All right, so I hope it is clear. All right, so to conclude the lesson or to summarize everything today, we have discussed wave motion, specifically what a wave is, and then how to describe a wave motion. So whenever you are giving or you are talking about wave motion now, know how to describe it using terms like frequency, wavelength, displacement, amplitude, period, phase of vibration, and so forth. Is it clear there? Alright, so we'll end our lesson here. Unless anyone has something he wants further clarification on. Alright, otherwise then, thank you very much for your attention for the day.